Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, we are going to discussing about the IMDb movie review sentiment analysis using deep learning. And also at the last, you're going to creating one web applications, which one you can run it on your mobile phone browser. So बिना किसी डर के हर हर महादेव बल के start करते हैं tutorial. In order to building the IMDb movie review sentiment analysis, you're going to use the dataset from the Kaggle. That's called IMDb dataset for 50K movie reviews. And if I go down it having two column in our data set in the form of CSV, and this is called review. I mean the review of the users and also the sentiment. Is it a positive review or a negative review? So using this data set, we are trying to building one deep learning model and try to testing it out with our own data. Well, so after downloading the dataset from the Kaggle, I got here one CSV file that's called IMDb underscore dataset. Actually rename it with underscores. And also you can see here, I create here one empty IP1B file. And for this case, you're going to be using here the Jupyter notebook. You can also use here the Google Colab or PyCharm itself. Well, so this our empty IP1B file. I mean, that's our notebook. So now what I can do, first thing first, I'm going to importing the dataset from a directory. So in order to load in the dataset from a directory, I mean the CSV file, you can using here the library called pandas. So let's say import pandas as PD. And also I'm going to import here the numpy. So let's say import numpy as np. So numpy is nothing but for multi-dimensional or scientific calculations, and pandas is nothing but for loading the dataset from our directory and also doing some visualization tasks. Okay, so shift enter and it will importing the package from my Python 3.8.5. If I try to check in this one, let's say print. Okay, otherwise you can also using here the Windows and R and open the CMD and type in the Python. And you can see my Python version is nothing but 3.8.5. That's my Python version. Okay, well, now what I can do, you can see there is some warning actually happening here. You can also ignore this warning. So let's say import warning because of just out of date of the library, because I'm using some library which one is interpreted, and right now Python 3.12 is also coming, but I'm using here the Python 3.8.5. Why? Because of the compatibility, right? So that's why sometimes a warning is actually coming up. So let's say warnings dot filter warnings. Okay, and I am simply going to ignore it. Okay, and shift enter. Now you can see no error is actually coming up here. Now I am simply going to load in the dataset from my directory. So this is my same directory, I mean same working directory. So that's why I can using here pd dot read underscore csv, and inside that I can pass here imdb underscore data set. Okay, data sets. Okay, data set dot csv. So let's assign it the variable called data, or you can say the data frame, because this is also a data frame. And now our data is loaded in our IP1B file, I mean our Jupyter notebook. Okay, so if I try to see the data dot head, then you can simply see the your data frame, the how your data frame look like. So this is the form of the data frame. Okay, now let's say try to checking the shape of the data. So let's say check the shape of the data. So I mean how many data are available in our data set. So you can see it having the 50K rows of the sentiment and two columns. So columns are nothing but review and the sentiment. So if I try to checking the type of the data, let's have a look type of the data. See, this is one pandas.core.frame.data frame, because it having the more than one column, so that's why it's in the form of the data frame. It's in the form of the data frame. Okay, this is a data frame, this is not a series. If you have just one number of column, this is nothing but a series. If you wanted to know more about the pandas, you can also follow my panda series that's available in my data analysis crash course. So here you can actually using here multiverse. This is the multiverse course, and this is also the another types of series they actually created. So here you can learn about the data analysis just like pandas, numpy, matplotlib, and so on. Okay, so link will be in the comment, I mean not a comment box, it will be the description. You can get it from here. Okay, and learn the pandas about it. Okay, that's it. Now what I can do, we now simply go into checking the head. We already checking the head. Let's checking the tail of the data. Okay, that's it. So you can see the tail of the data. This is the last columns of the data set. It having the negative sentiment, negative, and no one except the Star Trek movies to be high, like that. Okay, so this is how you can see the data and how can you load the data from your CSV file. I mean, comma separated value file. Now let's see, try to checking this how many positive review and how many negative review are available in our data set. So how can I do that? I need to go on our column. So our column is nothing but sentiment. Higher in our data frame. Now from the data frame, I am trying to start in the sentiment and try to do the value count. So let's say value counts. Okay, fine. Now you can see it having the equal number of positive and equal number of negative sentiment. Well, now what I can do, see, this is nothing but one textual data. See, when I try to building one deep learning or machine learning model, what I need to do, I need to making this target class in the form of numbers. Now the question is it a supervised machine learning or the unsupervised machine learning problems? See, it just having the two. Output. I mean, two output class. Let's call a positive class and the negative class. That's mean this is a classification task. So classification task means supervised machine learning problems, because supervised machine learning problem having two types. One is the regressions, and another one is called the classifications. Okay, classifications. So in this series, I hope so we do just one regression problem, yeah, but we are trying to covering here 6 regression problem on this multiverse series. And classification is uncountable because most of the classes, I mean most of the topics are based on the classifications. Okay, and also you try to do the unsupervised learning technique also, just like a clustering. Okay, clustering. Okay, that customer segment clustering, just like the way we try to build in this kind of problem series on the series also. Now this is one classification tax of machine learning problem, I mean supervised machine learning problem. So what I need to do, I need to just converting this positive to the 1 and negative to the 0. This is nothing but called the one hot encoding, also called the one hot encoding. Okay, or you can also say the level encoder. You can also say that like that. I also say the level encoder. Okay, one hot encoding, or you can say the level encoder. Let's try to drink some water. Okay, fine. Now what I can do is simply going to making this positive to the 1 and negative to the 1. It's called the level encoder. Okay, let's take in some shell. So what I can do is simply going to making positive to the 1 and negative to the 0. That's it. We'll try to building this one. Okay, let's try to do this one. So what I can do is simply going to replace it. So let's say data. You can also using the map. Let's try to using some another technique so that you can learn it. So replace, and inside is replace. What I can do, I am going to replacing from here. I am simply going to replace it from the sentiment. So you need to pass it just like a dictionary, and inside the sentiment, how many column you have, I mean how many classes you have the 2 classes. That's why it's also taking one curly brackets. So let's say positive, so let's make it positive should be 1, and which one is called the negative. Okay, negative. Let's make it negative should be 0. And also you need to making this replace equal to true, otherwise it will mismatch your data. So replace equal to true, I mean in your actual data set you will try to replace in your data. Okay, okay, not replace, actually in place, it's called in place equal to true. That's sort of good practice to do that. Yeah, let's try to do it, because don't change your actual data, but in this case the actual data should be changes. So let's say data dot head and checking this one. Now you can see 1 is for the positive, and you can also see the negatives. Okay, this is the for the tail. Yeah, here is it. You can see the negative, and you can see negative. Okay, I mean changes to the 0. If you try to check in the tail, so data dot tail, and then you can see all of them 0 because all of them are the negatives for the tail. Okay, this is how you can actually try to do this out. Okay, now you can also taking this value count also. Let's copy this out and try to paste it here. You can check in the value count. Yeah, for the 1 is nothing but 25,000, and for the 0 is 25,000. Cool. Now what I can do is simply going to building our deep learning model. So for this cases, what I can use, we can using here the LSTM, also called the long short term memory. Now the question is, why not RNN? Why not RNN? Because see one thing, this is the textual data. This is the textual data. Textual data. For the textual data, RNN cannot be actually predicting the data well. Because RNN means recurrent neural network. That's mean having recurrent connections. Recurrent connections. For the LSTM, this is the updated version of the RNN. That's mean in the RNN, it don't have the memory. In the LSTM, it have the memory because it has it having so many data, so many textual data in the form of the vectors. In the form of the vectors. That means there should be a problem with the memory. There should be the problem of memory, which one RNN cannot deal. That's why LSTM is coming to the picture. LSTM is coming to the pictures. So that's why I need to choose in the LSTM. Okay. Now let's see, for the textual data, better you can using the RNN or the LSTM. If you have just low number of data, you can using the RNN. Otherwise, you can using the LSTM. Okay, it's also having another textual technique that like just like the Guru. Okay, GURU, I think so. Okay, now what I can do, I am simply going to importing here all of the module. Which one is needed? See how you try to building on deep learning or machine learning model. You need to divide your data set into the train and test. I mean 80% for the training and 20% for the testing. So let's try to also import it. Let's say from sklearn dot model selections. So model selection, and I'm going to import here the train, test, and split. And also I am simply going to creating here one sequential model. So that's why I am also importing here the sequential for my layers. So let's say test split. Okay, then okay, it's already coming up. Okay, so from then TensorFlow. So make sure that your TensorFlow is also installed. That's a Keras dot model, and I'm going to importing here the sequential model. Then after that, I'm also importing here the dance layer, also the embedding layer, then also the LSTM layer, and also tokenizer. So sequential. Fine. Now from TensorFlow dot Keras dot layer. Okay, import the dance layer. Then firstly, it's called the embedding layer. Okay. Then we have the LSTM layer. Then from TensorFlow dot Keras dot preprocessing dot text, I'm going to import in here the tokenizer. Okay, 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 fine. Now from the TensorFlow dot Keras dot preprocessing from sequence, I need to import here the pat sequence, because I need to making this data in the from the pat sequence so that I can pass it inside my LSTM model, because this is a textual data. So I need to make it in the from the sequence. Okay, fine. So that's our library that is required in order to building this machine learning model. So can I import? Okay, sequential. Okay, fine. Okay, you put a package from the TensorFlow.keras.preprocessing sequence for the pat sequence. Okay, thoda mistake हुआ है, pat sequences. Okay, now fine. So from the sklearn.model selection, you input the train test split. Then from models, you input the sequential. From layers, you input your dance, embedding, LSTM. And then from the text, you input here the tokenizers. And then from the sequence, you input here the pat sequences. That's fine. Now what I can do is simply going to divide our data into train, test, and split. So let's say train, test, and split. Okay. Now simply passing the data, and let's say making the test size. Let's make it 0.2 for random state. Let's make it one random state so that it's not changing the state again and again. So let's assign it a variable called train data and the test data. So train data and the test data. Now the question is happening here, sir, why not you actually building your data in the X and Y? I mean dependent and independent features. See, it's just having the two columns. Okay, I mean the two columns. So why should we need to divide our data set in the X and Y? It's already divided, right? So that's why I'm simply going to pass it inside my train, test, and split. Okay, now shift enter. Now our data is divided, and we have the train data and the testing data. Now what I can do is simply going to checking the shape of that. I mean just checking the shape of the data. So this is the technique. Okay, shape. This is how the shape look like, and let's checking for the test data. Yeah, that's been divided the data set into the 80% and the 20%. Fine. Now let's do the data preprocessing part here. So see, this is the textual data. So that's mean we need to convert our data set in the, from the token or in the, from the vectors. So what I can do, we simply going to creating here one instance of the tokenizer. So let's say call tokenizer, and inside this tokenizer, what I can do, we can giving here the number of words. I mean, how many number of words should be the in our in one token. See, this is one full text. If I try to open here our data set, just to wait, here is it. See how the data actually look like. This is one data with the review. Okay, I think so it's just more amount of the 5,000 word. I can taking it at the for the text number of word. I mean, how many number of words are available. And also you can see here the br tag, because this is taking from the website in the from the HTML, so that's why it's coming up with also the tag. So what I can do is simply going to giving here the number of word. I mean, how many number of words should be the in one sequences. So let's say number of words should be the 5,000. So let's say making one way called tokenizer. Fine. Now what I can do is simply going to use this tokenizer in our review data. So let's say fit on, okay, fit on text, okay, text. And if I try to using here, let's say one data, can I use it like that? Let's say I love you. So if I try to checking one, okay, is it possible to checking this one? Let's say test. Okay, let's try to check the test. Yeah, okay, here is it. Okay, I can print in the test, right? It's a none. Okay, so yeah, it actually converted this data into the from the token inside, but we can checking it when you actually pass it inside the pat sequences. So let's try to pat it. Not I love you, I hate love. Okay, then let's say train data, data, and inside the data, what I can do, you can passing the review. When you're passing this data inside our pat sequences, that then you can actually see this one. Okay, it is now converted your data. I mean, taking the review data and try to convert this data in the form of the tokens. Okay, on the taxes. Now what I can do is simply going to pass it inside the pat sequences. So pat sequences. Okay, let's try to cut it out so that it look better. So let's say pat sequences. Okay, and inside this pat sequences, what I can do, we can passing here my tokenizer dot text to sequences. Now text to sequences, and now if it is text to sequences, I'm going to passing here my train data. Okay, train data in the from the review. Okay, in the from the review, now I can passing here the maximum length. So let's say max length, how many length should be there on the one input. So let's making here the 2000. This is nothing but for the number of word. I mean, how many number of word should be the in our data set, and the maximum length is nothing but the 200, so that you can, when you're taking the input from the users, make sure that your data should be in the from the 2000 length. Okay, 2000 not 200 length. Okay, fine. Now this is our extend data. Okay, okay, so let's try to copy this out, and I'm going to paste it here. So this is our test data. Let's try to do it for the testing, and now I need to using here the test data. So test data. Okay, so this is how we can actually using here our sentiment on your training data and the testing data. Now we simply going to token on our training data and simply going to convert our data in the text form. Okay, now you can see xtrain and xtest. Now if you try to checking here the print, just printing here the xtrain. So let's try to printing here the xtrain. Yeah, it will take time because it will converting your data in the number of sequences. So this is nothing but the numbers, some kind of numbers in the array. So this is the number for the array for the number one sentiment. I mean text number one. It's just having some random value. Okay, just having the random values, and it will be creating one on vectors. Okay, that's mean let's say I let's say I am Chandodhar. Okay, let's say I am Meshudhar. Okay, that's been for the I. It will, let's say it will initialize for I equal to 0, M for 1, Chandu for 2, and Dhar for 3. So what should be the next one? Next one should be the 0, and it for the 1. Now for the Mishu, it will maybe converted should be the 4, because 4 is not already have inside our data. And for the Dhar, it will actually making it, let's say 3. Okay, like this way. So it will actually converting this data in the from the sequence just like that, so that LSTM can actually get it from your data in the from the numbers and try to predict it out. Okay, so if we try to checking here, let's say X test also. This is also in the from the numbers in the NumPy array. Now, what I can do, we can also taking for the white train and the weight test. This is coming to the pictures that how can you actually building your data in the from the X train and the white train. And you see we're just passing the data. Now we are going to building our data, I mean breaking our data in the X train and the Y train. Okay, this is how you actually build it out. That's why I don't give you here any spoiler. Okay, so let's say X train Y train equal to, now from the train data, what I can do is simply going to taking the sentiment. It will be going to taking the sentiment. Okay, insert again here. Okay, just to write sentiment. Well, now for the Y test, let's taking for the test data. So test data, and from the Y test, just taking it from the sentiment. Okay, well, fine. Now if I try to checking here, Y train, this is nothing but the 0, 1 like that, because Y train is nothing but our target class. Okay, fine. Now it's time to building our machine learning model, sorry, deep learning model. I mean our LSTM model. So let's try to building here the LSTM model. LSTM model building. Let us start now. Fine. Now our model is nothing but called the sequential model. So what I can do, we can using here the model equal to sequential. Okay. And after that, we simply going to adding here one of them. So let's say add, and inside that I can passing here first embedding layer, because embedding layer is needed when you're passing your data in the from the text. You need to passing here also one input layer, which one is also called the embedding layer. Now inside this embedding layer, what I can do, we can simply go in here and apply input dimensions. So our input dimension is nothing but called 5,000, that actually already declared here in the tokenizer. So if I see this 5,000, and also giving here the output dimensions. So output dimensions, is nothing but called, let's make it 128. Then input length. Okay, input length is nothing but yeah, max length is nothing but 200. So let's make it 200. Okay, that's our input layer. Now we can add in here our LSTM model layer. So let's say add LSTM, and inside this LSTM there should be neuron should be the 128, and let's making here the dropout. Let's say dropout should be okay. There should be the any let's say to 0.2. I mean 20% of the neuron should be deactivated. How you need to be building here the LSTM model, and also try to using the recurrent dropout. So recurrent dropouts. So let's say recurrent dropouts. This is for the RNN. Let's make it out 0.2. Fine. Let's add here another model. There's a final model called dance layer, and inside here you can passing here the number of classes. I mean how many number of classes should be available. So you're just having one classes, because of it is just predicting here the positive or the negative, like this way. I mean, is it a positive sentiment or a negative sentiment? So that's why I'm simply going to passing here one in my number of classes. And after that, I need to using the activation equal to sigmoid. Okay, sigmoid. Why sigmoid actually? Because this is the binary classification tax. Okay, let's try to drink some water also. The temperature is so high, just like the 40 to 42 degree at the outside. So that's why मुझे थोड़ा पानी पीना पड़ रहा है. Okay, so now what I can do, activation is nothing but a sigmoid. Okay, well, fine. Now let's try to checking the summary of the model. Okay, थोड़ा थोड़ा zoom करना पड़ेगा शायद. Okay, so it's a model dot summary. Okay. क्या हो गया? Okay, let's call model dot summary. Yeah, now you can see the summary of the model. Okay, this is how your model look like. The sequential model is just having the 2000 input length and 128 the output dimensions, and also for the LSTM model having the 128 neurons, and for the dance clear it just having the 1. Okay, now what I can do, we can simply going to compile our model. Before fitting with your data, we can using the compile, so that our model should be compiled, and after that we can fit it on our data. So let's say model dot compile, and inside that I'm going to passing here the optimizer. Okay, optimizer, let's using here the Adam optimizers. Okay, then we have in the loss, so loss should be the binary cross entropy, because this is the binary classification task. So let's say binary cross entropy. Okay, fine. Then what do we have the matrix. So what kind of matrix we have? We just having the accuracy matrix. Okay, accuracy matrix. Okay, this is our compile of the model. So now let's try to fit with your data. So how can I fit it? We can fit it, let's say model.fit, and then we can passing here my x train and my y train. Okay, y should be the capital, or okay, yeah, y should be the capital. So yeah, let's make it capital also. Okay, then we need to using here the epochs. Okay, epochs equal to how many epochs? Let's say 5 epochs. Let's say batch size. For my case is 32 is okay for my local PC, but I am trying to using the Google Colab here, because it will take times in my machines. How I'm actually trying to building this one and training this one, it will take in time. So that's why I'm simply going to begin here the 64 batch size, because I'm going to using the Google Colab right now for the training part. Let's say validation equal to, let's say validation equal to 0.5. Okay, 0.2, not 0.5 split. Okay, let's make it 0.2 like this one. Okay, fine. Okay, now this is how your model look like. See if I try to making it one. Yeah, let's try to run it down. Let's see is there any error or not. Yeah, I see there is no error. There is no error right now. So yeah, we can, yeah, you can see it take really taking time, just like the 30 minutes for one epochs. So I'm already using the Google Colab right now and try to bracket enter with the kernel. So now I'm simply going to save it here. Yeah, you can also see here save file. Yeah, save options, it will saving the checkpoint. Now I'm simply going to pass this file in our Google Colab and try to do the compile, I mean to try to do the training part here. Okay, let's try to do that. So you can see here I upload here the code that we do in our Jupyter notebook. So I simply go on here, just click on the upload notebook and just uploading here this IP1B file. And also in this side you can see here I also upload here my data set in the from the CSV. You can also just click on here and click on the upload button, and you can upload your data set in these sections. Now what I can do, I'm going to running these shells, this shift enter, and also I am going to go on the runtime and checking the runtime type. Okay, just change runtime type, and your runtime type should be in the from of GPU. Okay, otherwise it will take times. Now what I can do, I am simply going to running all the shells, but before that I need to also changing the path of that. So for that I need to just click on here and copy the path, and I'm going to just removing this one, and I'm simply going to pass it here, and now shift enter, and I'm going to running all the shell from the beginning to last. Okay, here is it. Okay, so you can see right now actually Google Colab using the AI, the artificial intelligence, and you can also see here some visualization technique, which one suggests you some kind of chart, and also you can see your data set in the from the tables, and you can also see here the pandas.code.data frame and tail. You can just see your overall the data some kind of AI tasks actually happening here in your Google Colab. So you can see here it will take maybe 4 minutes for the one epochs. I mean, I think it will much better than using the local system, because in my local system it will take for one epoch 30 minutes. I mean, for 5 epoch maybe it will take in 1 hours, but it's better you can using here the Google Colab. So now what I can do for checking the loss and the accuracy. So what I can do, you can using here the model.evaluate. Okay, so for evaluate your model, so you can check use your evaluate model, and okay, evaluate, not evaluate. For evaluate your model, you can actually using here the model.evaluate, and inside that you can pass your testing data. So I think it's better I can training this out, then I can back again, because it will take maybe 15 minutes to training your whole model. And after that you can try to evaluate our machine learning model, I mean deep learning model, using our testing data, because we also have the test data just like the y train, a y test, x train, and the x test. And also we are trying to save our model in the form of is5. So it's better I can save it right now. So let's say model.save, and then later on I'm trying to actually evaluate it. So why save actually, see how in actually trying to share this model with your friends, or try to building a machine learning or deep learning model. You don't need to do this kind of text. Okay, just you can share this one with your friends. So what I can do, I can using here this model.as5 and shift enter. Okay, and it will save in this model in this folder. Okay, so I'll back again when the training part is completed. Okay, then we try to evaluate our model and try to building here the applications. Okay, so well, so now you can see here our model training is completed, and you can see after 5 epochs we got here 93% accuracy, and also 87% accuracy on the validations. So you can also increase the epoch size, and also the batch size increase or decrease, and whatever you can get your this kind of accuracy, right? So, and also in this side you can see here model.as5 is also generated. Fine. Now what I can do, I am simply going to evaluate our model for checking the loss and the accuracy. So for that I can use here model.evaluate. Okay, and after that I can pass in here my testing data. So that's my x test, okay, x underscore test, and also my y underscore test, for getting here our loss and the accuracy. So this one give me two value, loss and accuracy. So I can simply going to store it and try to printing it, this loss and the accuracy. So it will take 18 or 20 seconds for evaluate our model with our testing data, because this is training actually using it for the training data. And now this is the unseen data, and the unseen data, let's see how our model actually work and what kind of accuracy can got in our unseen data. Fine. Now you can simply going to print it out. Let's say print here our loss. Okay, print the loss, and that's our loss, and you can see 33%, and accuracy is nothing but 87%. You can also printing here the accuracy. Okay, just like that. Well, 87% accuracy right after 5 epochs. You can also increasing this one. Now simply I'm going to building here one predictive system and try to give here one text and try to predict it out. Okay, now it's time to building a predictive system. Let's call build, okay, sorry, building a predictive system. Well, so for that I am simply going to define here on functions. So let's say def predictive system, and inside that I am simply going to text, taking one text from the users. You can also checking this one, you can also taking this one as a review. So let's say review. Okay, and first when I getting this text from the users, so I am simply going to convert them into in the form of the token. So for that I'm simply going to using here my tokenizers. So this is my tokenizers. So it's better you can also saving your tokenizer so that you can also use it later on. So what I can do, I am simply going to taking one shell from here, and after that I am simply going to import here the job lib, and after that I'm simply using here job lib dot dump, and after that I'm simply going to passing here uh, my tokenizer. So tokenizer, and after that I'm going to giving here a name called tokenizer. Okay, so my runtime is disconnected. Let's connect it again. Well, so just because of the internet connections, my runtime is disconnected, so I connect it again. So let's use it here tokenizer.pickle file. Okay, now I can simply go into save it. Okay, shift enter, and it will save in this tokenizer in my directory in here. So I can also download in this model.as5 file because it's also needed. And now tokenizer.pkl file is also uploaded. I'm sorry, generated. Now it will also store it here. If I refresh it one, you can see tokenizer.pkl file. Okay, so later on you also using this one and try to building this one, this predictive systems. So now in this case, what I can do, we first using here these tokenizers, tokenizer, and after that I'm simply going to first convert these texts to sequences because it's needed. And now inside this text to sequences, I am simply going to passing here my review. I mean my user input that it coming from the users. Then after that, I am simply going to using here sequences. Okay, sequence. Let's make it sequences. Okay, just one inside and variables. I'm simply going to pass it here. Well, so now tokenizer is converting the text to the sequences. Now text to sequences is passing inside the pat sequences. So what I can do, I can using here the pat sequences. So pat underscore sequences. So these sequences, and inside this pat sequences, I'm going to passing here my sequences that is taking from here. And after that, I am simply going to passing here my max length. So max length is nothing but the 200 as we actually pass it how in actually building here our deep learning model. If I see just to wait, I think here is it. Yeah, you can see maximum length is nothing but the 200. Fine. Now inside that I am simply going to store it the variable called, let's say padded sequence. Okay, sequence. Okay, fine. Okay, that's our parrot sequence, and this is our nothing but a sequence. Okay, I mean tokenizer sequences. Now we're simply going to using here our model to predict here our sequences. So model.predict, so predict, and inside that I am simply going to passing here my parrot sequence. Okay, well, fine now, and then let us store it into the variable called prediction. Prediction. Okay. Now, if the sentiment is positive, I mean the prediction is greater than 0.5, this is the positive predictions. Otherwise, it should be the negative predictions. Okay. So what I can do, I am simply going to first return here the predictions. Just checking here this one. Then you can actually using here this if and else conditions because this is so easy. Okay. So our predictive system function is running. So if I using this one, and let's give here one text. Let's say this movie is okay, this movie was fantastic, fantastic and amazing. Okay, so let's see what kind of predictive system we can got. You can see here we got one array in the form of the value like 0.97s. I mean some prediction value we can get here. So let's say this movie was not so good, not so good, organize, like that. Okay, you can see 0.45. That's mean this is a negative sentiment. Okay, so now what I can do, we can simply go into creating here one range. Let's say if it is greater than 0.5, that's mean you can say that this is a positive sentiment. Otherwise, you can say that this is a negative sentiment. So what I can do, we can using here one variable called sentiment, and inside that let's say if the predictions, predictions, so this is under the two bracket. So what I can do, you can check in the index number 0 to 0. Okay, index number 0 to 0, you can using here, let's say 0 to 0, and let's running this one again, just to wait, so I'm simply going to return it here so that you can also clear it this one. Okay, and now you can see, just to wait, we can got here 45%. Now you can see we just got in here the raw value. I mean if the prediction of the 0 and 0, because it having the two brackets, is greater than 0.5, it's greater than 0.5, that's mean this is a positive sentiment. So what I can do, you can simply going to return it. Okay, so let's say positive. Okay, positive, so that's mean positive. Otherwise this should be the negative, otherwise this should be the negative. So what you can do, you can return here the negative. Okay, now we can simply return here the sentiment. Okay, fine. Okay, just return here the sentiment. Now let's stacking this one, and you can see negative sentiment. If I say this movie was fantastic. Then you can see it's okay. This movie, okay. I think this movie was, if the gradation is greater than 0.5, it is positive. Otherwise, it should be negative. But why it's getting the negative? Okay, let's try to also uh, use this one and see it's 0.40. Okay, this movie was fantastic. Okay, I think, okay, okay, because of the word I actually write in fantastic is the wrong word, so that's why. Okay, थोड़ा यहाँ पर आपको correct word देना चाहिए यहाँ पर fantastic. Okay, fantastic, that's why it actually giving me this kind of error. Okay, and now you can 63%. So what I can do, I can simply going to run in this one, and now you can see it's positive sentiment. Okay, let's say an amazing, then you can also getting here the positive sentiment. Quite good now. So now what I can do, let's try to also do some analysis, just going to using here analyzing. So let's say predictive system. Okay, and let's giving here another text. So what I can do, I have some text inside my mobile phone, so I'm simply going to using this one. Okay, so let's type it here. So let's say thrilling adventure, adventure with stunning. Okay, stunning. Okay, the word should be the correct visual. And let's check in this one. Training history, yeah, that's a positive also. Let's copy this one again and try to let's use another one. Let's say a visual masterpiece. Okay, yeah, it's also positive, I hope so. A visual masterpiece. It will be taking times. Yeah, positive. So let's taking another one. Let's taking let's say overall long and slow. Okay, it's negative sentiment. Now what I can do, so we can simply go into downloading this model file from here, and also tokenizer file, and try to using this model.h5 and tokenizer.pickle file in another Google Colab file. I mean, let's say your friend actually send you this model file and also tokenizer file, and now what you can do, you simply going to using here this file and try to predict it without doing this kind of lines of code, without using the training. So well, so our download is completed. If I see in my folder, and you can see here this tokenizer.pickle file and also model.as5 file. So now what I can do, I am simply going to go on here and click here new notebook, and our new notebook should be the open. And inside this notebook, I'll see that I'll actually explain that how can actually using this model file and try to also building here the web applications in using the Gradio library in Python. And you can also run it in your own mobile phone browsers. Well, so it's loaded. So just going to changing this one. Let's say model. Okay, let's make it model testing, and let's say web applications. Okay, application. That's it. Now I'm also going to upload here the file, and our runtime is also executed. Just change on runtime type, and it should be in the GPU, and click on save. Okay, now I'm going to go on here to click on the upload this model file to model file, and it is uploading. Just click on open, and it is uploading here. So well, so you can see here we have the model.as5 file is also uploading, and also tokenizer.pickle file also uploading in here. Okay, now what I can do, I am simply going to do the coding part here and try to loading this model file from this section. So you can simply go click on here and upload, click on the upload button, and you can select here your model file and the tokenizer file. Okay, that is model.as5 and tokenizer.pickle file. Just simply upload it, right? And after that, what I can do, I am simply going to write here the code. Let's say from Keras dot models, and I'm going to import here the load model, and also I'm going to import here the joblib because we have the tokenizer.pickle file. That's why you need to also using here the joblib. Then also I need to using here the path sequences, because for the testing purposes I need to using here the path sequences. So from TensorFlow dot Keras dot preprocessing, okay, and dot sequences. Okay, sequences. I'm going to importing here the path sequences. Okay, sequences. Fine. Now we need to loading here the model from these sections. Okay, so for that I can using here one variable called model and using here this load model functions, and inside that I'm going to giving here my path. So this my path model.h5. I am simply going to copy path from here, and after that I'm simply going to pass it here. Okay, so that's our model file. Now I need to also load here our tokenizer file. So our tokenizer file is in the form of the pickle file, or you can say the joblib file. So what I can do, we can using here this tokenizer. Okay, tokenizer equal to joblib.load. Okay, joblib.load, and inside that I need to giving here path of my tokenizer. Simply going to copy the path, and I'm going to pass it here. Okay, and after that I need to using here my predictive system model that actually do earlier. So if I go on here in my Google Colab file, I think here is it, just to wait. uh, Here is it. Yeah, we can copy this one. I'm just going to copy this one because it's needed, and I'm going to paste it here. Okay, this is our predictive system function that you actually used earlier. Now what I can do is simply going to creating here uh, just running these shells, and after that I'm simply going to calling this one. Okay, this predictive system. Okay, so for that what I can do, I am simply going to creating one variables called predictive system and creating one variables. So let's say this our review sentiment, and now inside this predictive system I'm going to giving here my text. So let's give here another text called, let's say, exciting plot medi let's say medicore. Okay, mediacore. Okay, mediacore. Okay, let's say medio okay, medio theory. Okay, then character okay, development. Let's see what kind of sentiment you can actually get. So just going to copy this one, and I'm going to see that what kind of sentiment you can got. Yeah, that's called negative sentiment. I think just because of uh, mediocre character development. Okay, that's a negative sentiment. Let's using here another one. Let's say visual stunning. Okay, visual stunning, but poorly, let's say written. It's also negative one. So let's see the sentiment. Yeah, that's a white. Yeah, that's also negative sentiment. Let's keeping here another one. Let's say engaging, funny, but somewhat predictable. Predictable. Okay, it's also maybe negative. Okay, yeah, it's also negative. That's mean negative things also working fine. So let's checking for the positive also. So let's say this is a amazing movie. Okay, let's see the review sentiment now. Yeah, this is positive sentiment. Okay, let's say another one. Let's call beautiful cinematography. Beautiful cinematography. Okay, cinematography. So I think this is also positive. Yeah, positive sentiment. This is how. Now what I can do is simply going to creating here these web applications. Now how can actually using how can actually creating here the web applications in our Google Colab? Yeah, you can using here the Streamlit, or otherwise you can also using the Flux. But in this case, I am trying to using here this Gradio library because this is really easy to use. So that's why what I can do, I am simply going to first pip install the Gradio, and let's say pip install Gradio. Yeah, it's installing this library. And after installing, also one thing, if I go in this runtime, if I check in the change runtime type, should be in the from the GPU. Otherwise, it will really take times. Okay, it's also installing this library. Now, what I can do, I need to using here the Gradio library and try to creating the applications. So for that, yeah, it's take time because it also is installing and building the FFmpy. So I'm going to importing here this Gradio. So let's see, import Gradio, and after that, let's input Gradio as VR. Then after that, I'm going to giving here a title. So let's say movie sentiment analysis application. Okay, applications. Fine. Now what I can do, I am simply going to using the gradient interface. So let's say zr dot interface, and after that interface, I'm going to first passing my functions. So that's my function, which one is nothing but called predictive systems, and I'm going to pass it here. So I'm going to pass it here, and after that, I'm going to giving here my input. So input is coming from the text box. So let's giving here text box. Simple. It's also simple than Streamlit. Okay, let's outputs. Okay, and outputs inputs. Okay, should be the inputs, and output should be also in the text box. So text box. So let's say text box, and also in the title, I need to giving him a title. So let's say title equal to title. It's a mistake. Okay, now what I can do, I'm simply going to define into variable called, let's say, application or app. Now I'm simply going to pass it app.launch. So app.launch. Okay, and inside is launch function, launch, not launch actually, it's launch. Okay, launch, LAUNC, launch. Okay, then share equal to true, so that we can share it, and so that we can also run it, this application, on our mobile phone also. Now you can see it will also generate here one link and importing the Gradio and collab notebook detected. Yeah, that's fine. And also you can see one link. Now what I can do, I can simply going to click on here, and now you can see, just to wait, it will open in this application. Yeah, you can see here the application is open. And now what I can do, I'm simply going to zoom in. थोड़ा zoom in करना चाहिए. Yeah. Now inside this review sections, I am simply going to giving here some text. Let's say a brilliant. Okay. Okay, a brilliant blend, brilliant blend of humor and drama. Okay, blend. Okay, BLEND. Okay, let's click on submit and see. Yeah, this is a positive sentiment. Okay, let's giving here another one. Let's say a heart winning. Okay, let's add heartwarming. Okay, let's say heartwarming, not winning actually. Heartwarming. Heartwarming. Yeah, right now. Heartwarming tale with unforgettable. Okay, forgettable character. Okay, character. Okay, let's click on submit. Yeah, this is also on positive sentiment. So let's also give here one negative. This movie was so boring and nothing to learn. I don't know if user can actually learn from the movies or not. Yeah, that's a negative sentiment. Okay, so this is how your movie sentiment analysis application actually work. Now you can see that how can we actually run in these applications using this link in our mobile phone and checking this one. So let's try to using here our mobile phone and try to checking this one, that's is really working or not. And also you can see these shared links expire in 72 hours. You can also using here this Gradle library to for the deployment. You can see for free permanent hosting and the GPU upgraded, run the Gradle deploy for the terminal to deploy in this space. So you can also using his Gradle deploy, and you can deploy it in the cloud. Yeah, but I'm not going to actually deploy it in cloud. It's your task to do that. Okay, so I'm simply going to open in this link in my mobile phone and try to show you that yes, it's really possible to run in these applications in your mobile phone browsers. So now you can see here our mobile applications and also this link that you can see in the sections. Okay, this movie sentiment. So now what I can do, I am simply going to giving here the review. So let's say this movie was fantastic. Okay, fantastic and amazing. So let's click on submit, and now you can see positive. We can also run in these applications on our mobile phone. That's really crazy. So let's click on clear. So let's say thrilling, amazing, adventure. Okay, let's adventure with stunning visual. Okay, stunning visual. Let's click on submit, and you can see this is also positive sentiment. Okay, let's click here also on negative. So let's say overall long and slow, and also nothing to learn. Nothing to learn. Yeah, here is it. Submit. Yeah, it's also say positive, but let's making it slow now. Click on submit. Yeah, that's called negative. Okay, your textual data should be in the correct form, so then it actually work. Okay, so this is how your application actually work, and that's it for today now. And hope you enjoy this tutorial, and make sure to subscribe to the channels, and don't forget to hit the bell icon, and I'll be back with the another tutorial. So till then, take care and bye bye.